Today we are going to start chapter 8. In chapter 8, we are going to talk about sequence and series. 8.1 is about sequences, and all the rest are the tests for the convergence and divergence of series. So after each lesson, you can put the test for convergence or divergence into this table. Today we are going to learn 8.1, sequences. After today's lesson, you should be able to list the terms of a sequence and also write a sequence yourself. Determine if a sequence converges and or divergence. In this chapter, we are going to deal with convergence and divergence a lot, and be careful. Today, we are going to study the convergence and divergence of a sequence. The definition of a sequence is a function whose domain is a set of natural numbers, the positive integers. For example, given a sequence 2, 4, 9, 17. So this is what we call A1, A2, A3, A4. And this sequence, each number in the sequence, we call the element or the term of a sequence. And the nth term, we use A of n. And if you look at the numbers here, 1, 2, 3, these are all positive integers. That's the domain, has to be positive integers. So if you look at the sequence, because we only have A1, A2, A3, we don't have A1.5. So this function, if we plot the sequence, it will be discrete. So let's have a look at example 1. How do we list the terms in the sequence? Example 1, given an, that's the equation 3 plus negative 1 of n, list the first 4 terms. So we start with A1. So if we look at A1, that means n equals 1. We plug n equals 1 in, so it's 3 plus negative 1 to the first, give us 2. A2, we plug in n equals 2, give us 3 plus negative 1 squared, give us 4. Similarly, n equals 3, give us A3, 3 plus negative 1 third equals 2, and n equals 4, give us L4 equals 3 plus negative 1 to the fourth, give us 4. So this is the first 4 terms of this sequence. Okay, everybody, you can try problem 2 and 3 yourself. And number 3 is a little bit different, because this is what we call the recursive formula. dn plus 1 equals this. Given d1, we have to use this relation to solve for d2. Try it yourself and let me know if you have any trouble. So this is my answer key for number 2 and number 3. The second concept I want to go over is a factorial. So factorial, we use a notation n factorial. Is defined as n times n minus 1, n minus 2 until it reaches 1. And we read it as n factorial. 0 factorial is 1. 1 factorial is also 1. So both of them equals 1. And 5 factorial will be 5 times 4 times 3 times 2 times 1, give us 120. How do we simplify equations with or expressions with factorial? Let's have a look at example here. Part A, 20 factorial over 19. So we just expand it, use a definition. 1 divided by 19, 18 until 1. So everything is cancelled except 20. This is our final answer. Let's look at D, n plus 1 factorial over n plus 2 factorial. N plus 1 factorial equals n plus 1 times n minus 1 until 1. N plus 2 factorial will be n plus 2 times n plus 1 times n times until 1. Now you can see everything is cancelled. Our final answer will be 1 over n plus 2. You can try BCE yourself and compare with my answer key. Here's the answer for BCE and E. You don't have to follow it. You can leave your answer like this. If you look at the graph of a sequence, it will be separated dots, so it's a discrete function. As limit as n go to infinity, if the nth term an goes to a number, if this is a number, we call the sequence an converges. Otherwise, it will diverge. The property of a limit of a sequence. If the limit of an equals L and bn equals k, the limit n goes to infinity, an plus minus bn is the sum or subtraction of the two limits. Same thing, multiplication, we can multiply the limit. Multiply by a constant, constant times the limit. Division, also the division of the limit. So let's have a look at this example. How do we find the limit? How do you claim if the sequence is convergent or divergent? So given an, this is the sequence. So limit n goes to infinity. A of n will be 3 plus negative 1 to the n. As we know, as n go to infinity, negative 1 to the nth power will be oscillating between negative 1 and positive 1. So that our answer will be doesn't exist. Because the limit doesn't exist, so the sequence diverges. Okay, let's look at number 4. So the limit as n go to infinity, a of n, which is n minus 2 factorial over n factorial. After we simplify it, we'll have 1 over n times n minus 1. As we know, as n go to infinity, this go to 0. It's a number, so the sequence will converge. So everybody, you can try number 2 and number 3 yourself and compare with my answer key. Sometimes when we take the limit, we have to use L'Hopital's rule too. This is my answer key for number 2 and number 3. Everybody have a look. Any questions, let me know. Next page is we have a theorem here, which we call the squeeze theorem. So given limit an and bn, if both an and bn equals the same number, okay, how do we find the limit of another sequence Cn? If you can prove Cn is between A and B, then it's like a sandwich. Both A and B will push the limit of Cn goes to the same number. That's what we call the sandwich theorem. For example, this one, the sequence Cn equals negative 1 to the n over 1 over times 1 over n factorial. How do you prove this converges? And also, how do we find the limit? This is easier if you can just do the limit as n go to infinity. Negative 1 to the n over this. So how do we evaluate the limit directly? So as we know, negative 1 to the n as n go to infinity, this part will be oscillating. However, the denominator will go to infinity. So plus 1 or minus 1 over infinity, the answer will go to 0. So we know it will converge to 0. In the textbook, page 559, they use the squeeze theorem to prove this. It's very interesting. Okay, everybody, you can have a look at page 559. And the homework is on the bottom.